always, so this is an open-ended lecture. I'm going to be in the code and just showing things. So as always, during these lectures, bring your questions. Let me know. If there's something I do that you didn't catch, tell me to expand on that. Sometimes I'll get excited and just go a little quick. Ask me to slow down or whatever. If there's something adjacent to what we're talking about you want to see, just let me know those questions. The whole point of today's lecture is to help you. I'm just guessing at what will help you. So if you know what will help you, let me know. Yeah. Homework 2 is over. Wait, what? No, sorry, what was the question? Oh, yeah. So I'm showing the structure of a router. I'm just showing you like tips and tricks of how to organize your code. So would that be something helpful to go over homework 2? I mean, we could pivot. Or homework 3. What specifically about homework 2? I'm not necessarily opposed to pivoting into that. Yeah. General code structure. I can talk about WebSockets. Like I just said, I can go any direction as long as there's consensus, as long as it's what the people want. It's for the people. Yeah. On objective 2 of homework 3. So handling WebSocket frames. Yeah, I think I can do this, and I can fit that into this structure, and kind of talk about the idea of what's going on there. Yeah, I can do that. I'm just formulating like how I'm going to fit that in. I think I can do that. I think that all sounds good. This isn't my decision anymore. I don't know what an API is either. Seems like one of those words that's just thrown around everywhere. That was kind of my answer to the 116 students as well. It's a very overused term in computer science and software engineering. Very, very overused. What I like to think of an API is just a set of behavior. Like, here are the ways that you can access this thing. So like when we import a library, we're going to have the API. Like, here are the public-facing endpoints that you can hit to be able to interact with this code. If it's a web API, here are the HTTP endpoints that you can hit, and that's how you can interface, that's how you can interact with this code. And then all the details, all the implementation, you don't care about if you're consuming that code, you just care about the API endpoints. So like if you're creating a class, then all the methods of that class, that would be the API. That's how you interact with that class, is just call the methods. That's your API. So any set of behavior, I like to call it an API. All right, so I'll get into a little bit of homework 3 about what to do after, so objective 2, so after we have the handshake, what do we do then? I think that's the question. If that's not what people want to see, let me know. But that's where I'll go. First, I got to get a little bit of revenge. At the end of last lecture, this code didn't work, so I want to make it work. But I want to turn it into an educational thing. I feel like this is too loud. I want to turn it into an educational thing because, after all, that's why we're all here. So I want to show you my debug process. So I did debug this. I went through my debug process, fixed it, and then I undid all my fixes so I can show you my debug process without showing you live where I'm panicking and can't get things working. If I had like 5 minutes at the end of last lecture, I think I could have done it. But I had no time on the clock, and I had to just call it. But I want to show my debug process. So I'm going to run this. This is the state the code was in at the end of last lecture. And I'm going to run this. Oh, my goodness. And I didn't. Oh, I know why. I'm like, why didn't that give me an error? That should give me an error. So I'm going to go get my error. And I'm going to look at my error. So when I get a request, Python's going to create an instance of my TCP handler. It's going to call the constructor. And during that constructor call, when I look through the stack trace, I can tell that during that constructor call, I'm getting an error. So right here, I'm getting this. My TCP handler has no attribute router2. Yeah, I did rename that at the end of lecture, right? I renamed this router2 because I thought there was going to be a name conflict with another instance variable called router. So I named it router2 to get rid of any potential name conflicts. That didn't work. And I'm still getting no object router2. I know the library itself isn't going to have a variable called router2 because that's a terrible name. You shouldn't name anything router2. So I know I'm not having a name conflict and no attribute router2. I'm going to look right here. I am creating a router2. It's right there. And then some of this I just had to rely on memory and experience to remember what was going on wrong here. And I actually did this during lecture, but then I undid it in like my panic state. But the super constructor call has to be the last thing in a Python constructor. If you're calling the super constructor, it has to be last, not the first line. In some languages, it's the first line. In Python, it has to be the last line. That one got me. But that doesn't fix the issue. I'm going to refresh this, restart, go to the page again, and it's still broken. And I don't get any errors. I don't get any response. Nothing's really working. And here's where things get more interesting in how I'm debugging this. So I know when I get some data, I need to go through my router and process this request. Nothing crashed, so I'm going to hope that I'm getting some information. So I'm going to set a breakpoint right at the point where I'm receiving a request. I'm going to use the debugger and debug my code. We have something called the debugger. Why wouldn't we use that to get rid of bugs? So I'm going to run my debugger with a breakpoint right at the moment where I'm first receiving data from the user. I'm going to send a request. My breakpoint hits, and I'm in the debug process at this point. So I'm right at the first line where nothing happened yet. I have self, which does have router2, so that's cool. I got all my routes here. So things are looking good. I got the routes that I expect to have. I'm happy about that. That my constructor ran well at this point. And then I'm going to advance. I can see received data is in bytes, get, hello, HTTP 11, host, connection, keep alive, cache control, all my headers. Cool. That looks fine. That comes from the browser, so I don't really have to debug that anyway. Browser's going to do its thing. I'm going to create a request class. I'm going to step over this. I don't want to step through all of my parsing code. I'm going to step over that and then check my request, make sure it has all the information that I expect. The body is empty. It's a GET request. I expect it to be empty. All my headers are sitting here. Looks good at a glance at the very least. The method is GET. The path is /hello. Everything looks good there. Pretty happy with that. So that code's working, and we tested that last time. I expect that to be working. So nothing too much jumping out at me. Now we're going to go into the router. This is untested code. I was rushing to try to get it done by the end of lecture. I threw code together pretty quick, and it's the last thing to do, so clearly this is where my bug is. And we're going to take a look at what's happening when we get into my router. So I gave my router a handle method. I gave it the request and a reference to the socket. So my request has all that information we just looked at, all nice and parsed in an object. Contains my state and behavior of the request, just like I want. Everything's parsed, everything's looking good there. We just looked at that. I have socket, which is a reference to a myTCP handler, which importantly has the request. I don't know what I'm looking for here, but has the request, which is what I'm going to use to call send all to be able to send my stuff out when I'm done. Has access to the server, has access to sockets, has all kinds of good stuff in here that you may or may not find useful. And a router, I guess that's not too important because I have access to the router already. I'm in the router. So self is the router. It's a reference to the same router. We should be able to match the memory addresses, actually. self router 60. So this router is a reference to the same exact router that we're in. I'm going to use self dot instead of socket dot router 2 dot whatever. All right, so self dot routes. This is where I added all my routes. Remember, I added these as lists of size 3. I wouldn't necessarily recommend this unless you're trying to cram this into a 50-minute lecture. But I have lists of size 3, and then I have this kind of made up interface that the first element is going to be the request type, second element is going to be the path, and the third element is going to be a function that's going to be called. So I have two paths, get hello and get goodbye, both having functions, and I'm going to iterate through these and see which one is going to match my request. So I have my request, which has the method and path, and I can already start seeing my bug creeping up right here. So for route, this route, get hello function, if the method is route of 0, the method get route of 0, that looks good, and request.path equals route of 1. Path slash hello, route of 1 slash hello, and there's my bug. I got the wrong slash. F me, right? So I got the wrong slash. These are going to be false, not going to match, not going to match. Didn't match either of my routes, and I don't have an else here. This is where I would have somewhere here, if I don't match any routes, that's where I'm going to have my 404. I didn't add that for this one. I don't want to get lost in the weeds in what we're doing here. But that's where I would add it. But I can see my bug, so I'm going to go to my router and switch my slashes. Set the debugger. The debugger's done its job. Run this. Oh, yeah. And I still get an error. I don't need the debugger for this one because I get my whole stack trace because it's a legit error. The debugger is going to really help you with them logical errors, or if you get an error like this, we can set a breakpoint right before the error so we can look at the state of absolutely everything. This one was a lot easier to spot, though. I have length of bytes, which doesn't make sense at all. I'm trying to take the length of a type. Object of type has no length. I wrote bytes instead of content here. It's just a straight up typo, but the stack trace was able to tell me pretty clearly that, hey, you got a typo there, you wrote the wrong thing, what are you doing? Fix that, and now this should be working. I believe that's the last bug. Hello, goodbye, see ya. I got my routes working. So that's kind of a few different flavors of debugging. One, just looking at the stack traces if you have a legit error. But two, when I didn't have an error at all, I'm going to run that debugger and trace through my code and check everything that's happening in my code, make sure things match up. I got to that point where the slashes are going the wrong way, they're going opposite directions, bug, fix it, done. At this, okay, so now I want to, where did I create my, simplet paths. So let's pivot into WebSockets a little bit. So how would we fit WebSockets into this structure? I'm going to combine these two things instead of just talking about WebSockets, because I feel like I did already talk about this, just straight up WebSocket stuff. But how would we fit it into this structure? So what I would do is have a path. Let's call it WS path. Here's my main. I'm going to add this path. WS path. Don't call it. Importantly, if you are setting this up, and I keep wanting to say IntelliJ, but PyCharm keeps wanting to think that I want to call the method. This is very different than this. I don't want to call the method and pass the return value of the method or function at this point, and pass the return value of the function to this method call, the add route method, I don't want to do that. I want to pass the function itself. I want to pass the whole function over. So make sure you don't have those parentheses. Those parentheses make it a function call. I want to pass the function itself. So now whenever we get a GET request for WS, and this is once you have your server set up, this is how easy it is to add a path. Once I get a GET request for WS, this method is going to be called. I go to my paths, and I know that when I'm in here, I already got a call, I got a request that's a GET request for /WS, and I have all the information from the request right here. So it's a request.headers, get me sec, WebSocket, whatever it is. I don't remember the capitalization off the top of my head. But you'll get that key, you'll process the key, process key, and return accept. You're going to do all that stuff for the handshake. We're going to send the 101 switching protocols. No information to send. So that's objective one. Obviously, I'm not showing all the details here, but you would do the WebSocket handshake, and you would also want to generate a username. I have that code given to you. Random username. Where you're going to generate a random username. That's what you would do right here. And then we don't want to hit the end of this method. Once we hit the end of this method, we hit the end of our router. This will return. That goes back to main. This returns. Then the whole handle method returns, and the whole socket shuts down. We don't want that to happen. So we need to stay in this path. So right here is where we'd have our well true. And we would stay in this function call for the rest of eternity. We're going to stay right here. We have access to the socket. I'm doing the wrong thing here because I don't have my type set up. I'm going to set up my type hint just so I have, I don't know why I'm doing this, but just so I have some type hints. From main import my TCP handler. I could just go to the other file and look it up, but I didn't feel like it. Dot I might have to. Socket dot. Request is my class. I'm just being stubborn at this point, but fine. Request.receive. Oh, request isn't my path. Socket.request. Why isn't it showing up? And then in this, I'm going to get my WebSocket frame, buffer if needed. And then parse my WebSocket frame. And I'm going to return anything if I need to send out WebSocket frames. For your chat messages, you're going to return, or not return, but send a WebSocket frame to all WebSocket connections. How do you do that? Good question. So right here, when you generate the random username, you also want to add this connection to a shared data structure. So for example, let me do it with the hello path, for example. But you'd send this to a shared data structure, and then right here, you would iterate through that data structure and send the frame to all the connections. So we can do this. There's a few ways to do this. How did I demoed this before. How did I do it in my other demo? It was way before you had to care. So let's get it now that's more timely. I just want to know where I put it. I put it right here. So let's do that as a class variable. So I'm going to create that as a class variable of the my TCP handler. There is an issue with this that some of you have ran into, and I still don't know exactly why this is the case, but if you create no, that was with global package variables, I believe. But if you need to access that from this class itself, no, that was the package level. If you declare them up here, we ran into that issue. I don't think that's an issue. But I'm going to create it as a class variable in my TCP handler. Connections equals some list. And then in my paths, I already have my TCP handler imported. So I'm going to say my TCP handler, the class dot connections dot append socket. And let's abuse goodbye a little bit here. Print. You know what? We're talking about the debugger. Let's just set the debug point. What? If you declare it out here, for some reason inside this package, you'll get a different variable than you do from outside the package. So if you're declaring it like at the package level, at the module level, I would recommend creating a new module just to store your variables, where they never have to be accessed from that module. You just import it everywhere else that you need it. If you create it as a class variable, you shouldn't have that issue, but I feel like we did run into something. I feel like I was debugging something one time where we did run into that issue.
So what do you actually add to connections?
Oh, I didn't. Oh, yeah, I did. I added the socket directly.
What's the socket? Is that just for the class?
It's the whole socket. When you do self right here, like you would do, I've showed this before. You would do self.sendAll or self.request.sendAll.
Oh, that's self is the socket?
Yep, right here. Right there, baby. So I'm passing self to my router as the socket, and I'm passing socket to my routes. So this is the same as self in receive. So I'm going to store all of those. Let's run this in the debugger. Let's go to Opera. Hello. Get rid of that breakpoint. Let's go to Chrome. Go to hello. Let's go to goodbye, which hits my breakpoint. And I should be able to see, it's not in scope right here. Handle, self, this is a reference to my TCP handler. If I go to connection, see that's so weird. It's like different variables at different scoping levels. Why at this scope don't I have access to the connections? Let's do it this way. I don't know why you get multiple class variables. This never made sense to me. It's just something we live with. What?
So is there like a separate request type that we send when we to the other sockets when we do AP on the comments, or does it accidentally like add it twice and just updates the list?
Yeah, you got to write the code. I'm just showing you like how to use Python, I guess. Something I don't think I should have to show, but then of course, at the same time, I got tripped up on it, so you have a fair counterpoint. But I have a data structure here. From this class, I have access to the list that I added to, but for some reason, in other scopes, I don't have access to the same variable. This is something that trips me up with Python, so it's fair. But I have access to both of my sockets here. So if right here, I'm doing this connection stuff, adding to this list, and then right here, when I need to send all connections, I just loop through my list and send all on each of those. Well, I declared it right here. You could also go up here at the package level. You can put this in several different spots. You could pass it through your functions. Then it's more clear how it's moving around through the code. But as long as you have some shared data structure that's shared across threads. Any questions on this before I move on to the next thing? This is like the general structure of, like even if this is in your giant receive method, where am I? Even if this code is in your giant receive with all the elifs, you'll still have to do something like this. Once you send the 101, get that username, update your data structure, and enter the well true to parse WebSocket frames. That's where you'd start with task 2. Which I think is a little more than I should give, but it is what it is. But while I'm giving away stuff, does anybody have questions? Thank goodness, it's 3:30 already. All right, moving on. So we have this other big question in the course. Of what the hell are project reports? That's what I want to talk about right now. So here's a very simple Flask server. I was going to do some live coding with Flask, but I think that's a waste of our time to just do that. But so I'm just going to start with this very simple app. With my router that I just showed you, what we were doing is building some way to say, when I get a GET request for this path, do this thing. That's going to be common across any library that you import, any web framework that you import, that you're using in your code, that you're using for your project. You're going to have some way of doing that. Flask's way of doing that is using annotations on functions. This app.get, whenever I get a GET request for some regular expression, and if I were to expand the router that I showed, I would, instead of exact string matching, I would move to regular expressions. If this string starts with image upload, for example, or image, then I know that I'm calling my code that's going to read the image file name and then do something with that. You would add that functionality, would be the next thing to add to that router I showed. So if I get a request for the root, I'm going to grab my HTML. Flask has a make response method just like the just like make response that we had, adds all the headers and stuff. Actually, just returning something will do that as well. It'll automatically call make response. Send from directory. This is going to handle all of your safety stuff, making sure that the file that's sent comes from the directory named public. So if file name has some trickery in it, where somebody has some slashes and is trying to navigate your directory structure, send from directory handles that. And we also have parameters here. If I get slash and then something else, some file name, I'm going to send whatever that file they requested is, and I'm going to add my no sniff header and respond with that. So the framework is meant to narrow down your code, so you're just worried about the functionality, and then the framework is going to do all of the stuff, like most of the stuff that we do on the homework. And my question for you with the reports is, how does your framework do all of that stuff? This seems like just magic. Knowing what we know about web servers from going through 2 homeworks at this point, we know that there's a lot going on here with this code. There's all kinds of header parsing, HTTP parsing, looking for new line characters, opening files and sending them as bytes, setting the content length, buffering. All of this stuff is happening in this 29 lines of code, 28 lines of code. All of that stuff is happening here. We're creating a TCP connection and then reading bytes off of that connection. Lots going on here. Everything that you've coded is happening in this thing. Well, not multi-part forms quite yet, but it's similarly easy to do multi-part forms. We're using a framework. You just import, do multi-part forms, and then just do multi-part forms dot do it, and then it just does it. It does all that stuff that you're coding. So with the reports, my question is, how does this work? And I want to show you what I mean, what we mean by the reports and what you need to do. So there's 3 reports you need to do. One about the TCP stuff. How does your framework actually do TCP? Where does it actually use it? 2, where are you parsing requests? I think I narrowed that down to just headers. I forget what I exactly landed on. I was passing around a whole bunch of ideas for that one. And how does it do WebSockets? So those are the 3 reports you need to write. And I want to talk about what I mean by these reports and how to actually handle them. So what you should do is actually go through, well, I have some of it open right now, is actually go through the code for your library and find the code that actually looks like your homework code that is being called when you run your server. You need to actually dive into these libraries and see how they work. And specifically, I want to see something that's going to resemble a stack trace, starting with your code and then showing all the steps that get down to some homework-looking code in the library, which can be a daunting task. It is pretty tough to do this, which is why I want to show you, get you started and show you how to do this. So you can just look through the code. I don't even know if I'm going to do this. Maybe I will. I'll find Flask, and I can look through the code here. App, I know I'm creating one of those, and I can see a lot of code, a freaking lot of code. And you could just like look through all this code and try to figure out what's going on here. One, I can look at the imports. I'll warn you right now, you're going to go down some lengthy import chains. If I look at the imports for Flask, I'm going to find a lot of this workzug, which I never looked into exactly how to pronounce. I probably should do that. But I think it's workzug. This library does a lot of the heavy lifting of Flask, and in fact Django as well. These Python frameworks like to use this library for a lot of the heavy lifting, a lot of the low-level implementation stuff. If you find yourself in this workzug, if you're using Python and you find yourself in this workzug library, you're probably on the right track. So in workzug, we can kind of look at something that looks like something we might want. I'll go to routing. Sounds fun. And when you're navigating these things, I recommend doing it in an IDE where you have access to Control or Command click. So I want to find the definition of, say, this map. I'm going to hold Command and click on it, and it's going to take me into that library and into where that is defined. And that got me to a routing package with over 1,000 lines of code. I also see there's an HTTP package. I'm probably going to want to be here at some point. Ooh, some regular expressions. This is looking good. This is looking like something that I might be interested in. Looks like it's probably doing URL encoded stuff, possibly. We got some header names. That looks good. Ooh, HTTP status codes. We're definitely in the right spot here. So that was actually pretty quick, where I already got this code that looks like the code that I'm interested in for my reports. I still have to find the whole path of how my code gets to this code, but I can see a lot of good code here already. Items.append key to quote header. This might be where headers are being parsed. HTTP header. Oh, dumping a header. I want parsing headers. But this is where a lot of we got to a lot of the good stuff already. But that can be tricky to do. So another thing I recommend, which we just saw in debugging my code, I'm going to set a damn breakpoint. So I'm going to get rid of these, actually. And I'm going to run this server with a breakpoint. I'm going to go to my app so I can hit that breakpoint. And what this will do for me is something very useful, is give me this whole stack trace. Now, this won't be a be-all, end-all. It won't give you, like, just copy this stack trace into the magic section of your report. But this will give you a lot of clues of what code is actually being used to run your server, to make your server happen. Yeah?
You have to explain things like, that app.get. You have to explain what that app is.
Where do you see that? App?
App.get.
Is it on the screen right now?
No, it isn't.
Oh, the annotation. If that's part of your explanation for one of the 3 reports, then yeah. So at some point, that does make the routing happen. I didn't specifically say routing in the 3 reports. Maybe I should have. But if it's related to one of your 3 reports, then yeah. And you would say, that's an annotation. You would say, the library uses annotations to mark the paths, and then it grabs those paths at those annotations to be able to make the things happen. But I can go through this stack trace and kind of watch how my code actually got called. So one level up, one stack frame up, I'm in the Flask library, I'm in the app class, and it's this self.ensure sync, self.view functions of rule endpoints, rec view args, a whole bunch of stuff that's going to be kind of nonsensical. But if I look at what self.view functions is, self.view functions, I can actually see my paths here. I got the CSE 312, which is a function, static, which is a function, and these are matching my functions right here. That is a reference to the function that I wrote and said, hey, app.get / that added that told Flask to add that to this view functions. Send style, and static. Where did static come from? I didn't specify my static files at all. How did we get that? It must be a default of some sort. But anyway, I can see my stuff there, so that's how my paths got in there, or that's where my paths went, and that's where my function is being called, the self.view functions. This function call right here with these arguments, that's how my code is being called at the first level, at the very first step. If I keep going up, I can see how I got there. We can look through all of the code of how to get there. We could even, well, I'll say that for a bit. Full dispatch request, WSGI app, and this step right here, self.app, making this call, This is where we jump to the other library, and this is where app is actually going to be an instance. Let's see if we can see it in here. Where app, self.app, is actually going to be a reference to a Flask server. This library will take a server at some point during creation and use that server to call all of do all the stuff that it needs to do. That server can be a Flask server, it could be a Tornado server, it could be a Django server. This library doesn't care what server that is, as long as it implements the right API. As long as it has the right methods to call, has the right interface, it's going to be able to do what it needs to do with that app. Yeah. Yes. Yeah, you have to have some explanation. You need to show us that you understand the tools that you're using. That's the goal. Whatever you need to do to show us that.
So I actually have to say it opens up this library and does how is it line by line?
Not line by line. Like, you don't have to understand what all this code does, but you need to understand that Flask uses workzug, and at this call, that's where the handoff happens. I don't need you to understand what the parameters are and all this stuff. I don't need you to decompile the entire library. But you need to say, this is where workzug hands it off to Flask, is this line right here. Yeah. Yeah. What? Yeah, you don't have to go into extreme depth, but you need to... Like for each step of the traceback, you should have a sentence or two that says, this is where this happens. That's what I would expect. But we can see our Flask server, and if we keep going up, we can see all the calls that happen when a request is made until we're up to an HTTP handler handling the method. That's not exactly where I wanted to be. Right here, I think, is where I want to be, where we can see our information about our connection, and we can start seeing things that are looking like our TCP code when we're first reading from the TCP socket. We can get things like the client address and things like that, which I think I got to go up a little bit higher here. So we have this request object. Oh, it's already parsed at this point. And things will get a little weird at this point. So here I'm at some threading code. I don't really want to be in threading. So I got to go up a little bit. This is Python code, right? So at this point, I've made it all the way to Python. Right? Yeah, I'm in Python at this point. And I happen to be, which I can see right here, but I happen to be in... Where are we? Base server. Oh my goodness. This file's way too big. We can do this. I'm just going to collapse this whole thing. And we're actually in TCP server. No, we're not. We're in one of these. Threading mixin. God, there's so much stuff. Threading, base request handler. That's good. Streaming. I can see it in the stack trace. I know we're in there. Anyway, we're in the socket server. No, we're in socket server.py. I messed that up. But we were in the TCP handler class. This is where our TCP stuff is happening. And then somewhere in here, I'm running out of time to actually find it, but somewhere in here is where your headers are going to be parsed. This is the pipeline of how things are getting parsed. It's not going to be exactly in the stack trace, but it'll be adjacent to it. Your headers will be parsed, and then it'll go down this stack trace to get to your code. And one final thing, because I want to make sure I get to this one, to actually find where your TCP stuff starts, setting a breakpoint right here, right at the beginning of your app, and tracing through what actually happens when you call app.run. This, we don't just go to the stack trace immediately. We're going to have to jump into these things and trace through. See if I can do this quickly without skipping over the good stuff. You'll obviously go through this a lot slower when you do it and pay attention to it a lot more. Getting the host, getting the port, set some default configurations, show server banner, import from WorkZyug, run simple, use debugger. I'm probably going to skip over it and all this. Getting the socket stuff set up. And right here, socket.socket. So this isn't going to use the socket server like we use. It's going to use the sockets directly. So right here, socket.socket is creating a new socket connection, which, let me set a breakpoint. And you can set breakpoints in libraries, by the way. Let me restart this, because I skipped over a good bit right there. We can go into this, where we're actually in the socket class, and this is where we're creating a TCP socket. So if you want to find for your library where you're creating that TCP socket, you set that breakpoint right at line 1 where you're starting your socket, and just trace through it all. Trace through the code. And it can really make things a lot easier. Yeah.